key parts of this equation are the roots or zeros where it crosses the x-axis, the y-intercept. We can find that when x is equal to 0, we plug it in. When it's in this form, not any of the other forms, but only in the general form, that c, that last number, is the y-intercept. The direction of opening is determined by that leading coefficient. If it's positive or negative, it indicates if it opens up or opens down. So negative is going like that. Okay. For positive, it goes in this direction. Okay, so that's negative. Those are positive. Now, you may not have noticed this, but the A value also gives us scale. So the 1/2 versus 2, the shape is slightly different. Now, it's hard to tell, but this is going to be, looks wider, but in fact, I want you to understand that this is a vertical, this affects the vertical. And this is a vertical compression, so it squeezes it down shorter. So it looks wider, it's really shorter. The 2 stretches it vertically, so it makes it look thinner, but really it's not thinner, it's taller. Okay, so I want you to start describing it in terms of the y characteristics and not the width. Okay, I want you to express it in terms of its height. So that A value, if it's greater than 0, what we call it a vertical expansion, so it's taller. Okay, although it looks thinner, it's actually taller. If it's a decimal value or a fractional value, it's wider. Okay, so in this case, the 0.3 indicates it's not wider, it's shorter. Okay, and it's all relative to A equals 1. Okay, so here again, since A is negative, it's upside down. A is positive, it's right side up. So these are some key features of the graphs that we want to identify, because we want to know which way is it facing, and we also kind of want to understand the shape of it as well. So those are things that we're going to start figuring out. How can we relate those pieces to the different forms of the quadratic function? Okay, and we're going to look at those different forms in the next day or two.